Hi guys, welcome to ShoutingElectronics. I just want to show you something that I came across on one of my customer sites today and a workaround that we're going to do to prevent the problems that they've experienced. Let me show you what I mean. Okay, so this customer, they've got their house over here. Yeah, that's a house. And then at the bottom of their garden they've got a small little tool shed. And they wanted an alarm linking the tool shed to the house, but there's a driveway and there's no spare conduits to get under the paved driveway. So what they wanted to do is have an alarm sensor in the shed linked wirelessly to the existing alarm system in their house. So they got somebody to basically do it like this. Okay, this is a normal inside PIR motion sensor for an alarm system, and this is a remote control transmitter. Now what they've done is they've hooked the remote control transmitter up to the alarm sensor, and they just put the button in skew so that whenever the sensor triggers, it's supposed to be sending a signal. But as you can see, the way they've wired it up, or the way it's been done, whenever the sensor picks up motion, it turns off the transmitter. And when there's no motion, like you see now, the sensor's off, the transmitter's transmitting the whole time. Which is basically what it was doing for several days, which also flooded all the other signals and that. So people in the nearby area would have had trouble using their gate and garage door openers and everything like that. And it's just a bad way to do it because the transmitter was running the whole time. When I found this out on site, I actually checked. The receiver wasn't pairing to the transmitter anymore. The transmitter itself, although you see the light coming on, it's not actually sending a proper signal. It looks like there's a fault with the chip inside this transmitter. So it probably ran just for too long, which it's not supposed to do, and it died. Let me show you how they've actually wired this. Okay, new piece of paper. So let's open the PIR motion sensor. And drop the screw, that's good. And let's open up the remote control transmitter. And drop the button, okay. So basically what you got here is the remote control transmitter is just getting powered. Instead of its battery, it just gets 12 volts fed through the sensor. If you look at the sensor, you've got a positive and a negative, and you've got two normally closed terminals, one over there and one over there. So if we go to our piece of paper, make sure we're in focus. So they've got your positive and negative coming in from the power supply that's in that building. Okay. Positive goes into the PIR sensor, okay, and positive carries on through and goes to the remote control, positive on the remote transmitter. Then negative also comes in to power the PIR, the motion sensor, and from there it runs through the normally closed switch in the motion sensor, the normally closed contact, into the remote receiver's negative, remote transmitter's negative. So basically, the way this normally closed terminal works means when there is no motion being detected, it's closed and it's powering the transmitter. When there is a motion being detected, this little switch or relay opens and the remote transmitter loses power. But that's the wrong way to actually do it. For this type of setup, just a quick and easy remote link just to a tool shed. The reason it has to be done the reason this system is working like this is the older alarm systems, the older alarm PIR receivers used to have a relay like this in it, which had a common terminal, a normally open and a normally closed terminal. In that case, you would have easily just wired in through the common and through the normally open circuit to the remote, so that it's normally open until it picks up a signal. When it picks up picks up motion, it closes and triggers the remote. These newer newer alarm sensors don't actually use the relay anymore. You can't actually. You used to be able to hear the relay clicking in them, but let's take a look at this one itself and see how it does it. Because they've done away with the relay. So let me switch off the power. Yep, power's off. Okay, this sensor, unlike the one at the customer site, does have a read relay in it. Over here, this metal can here. But they're only bringing two outputs. They're bringing the common and the normally closed contacts. They're not bringing the normally open. So there's two ways to go about modifying this. We can either go and see which is the normally open contact on this relay, which looks like there might not be, because I only see 4 terminals here. So it'll be a coil, and then the 2 normally closed. If it had the third one, you could just, the normally open terminal, you could just run a wire out from there. So we need to figure out how to interface either this one or one that's got a transistor-based switch on it to operate the remote control by inverting the logic. That'll mean if the sensor goes faulty, they can just go and swap it out like for like, and they don't have to worry about figuring out modifying it and soldering it and that, because that's not really an alarm tech job description. So let me get another piece of paper and then I'll show you what my plans are. Okay, so here is the plan, what we are going to do. We could try using transistors and basically switching the logic from a logic high to logic low, but then we have to worry about the current draw of the transmitter, and resistance drops through the current limiting resistor, or voltage drop through the current limiting resistor and through the transistors. So we are going to actually just go and do it the quick and easy way, which also works out cheaper for the customer, so they'll be happy. Okay, so there's our positive and our negative from the battery back to power supply. Okay, here's our PIR elements or units, taking negative and positive in there. Okay, then with access controls such as gate motors and alarm systems and that, they love switching the negative, so keeping a constant positive and switching the negative. So let's go. Let's put our transmitter over this side here. Okay, so our transmitter's over there. We're going to give it a positive. Okay. We're going to give it a negative directly onto the battery terminals. Okay. We're not going to be switching power to the remote. Why it should be, because we've got a perfectly good switch on the unit. So we can just give it a constant supply, and when we want, we just use the small relay, such as a read relay or whatever, to push basically short the terminals like as pushing the switch. So short those terminals, or those terminals, we'll measure that out, and then we should be good to go. So let's take the negative from the PIR. Okay, it's going to go through the normally closed terminals, and it's going to go into our relay. Relay is going to go back to negative. Then, easy, transmitter's got, we're going to put a wire across the switch, and we're going to have the relay's terminals there. Now, we have to think about this, okay? When the PIR says it's safe, okay, then the connections are closed, okay? PIR sees motion, then the terminals are open. close and open. Hope that's not too messy. Okay, so now let's see. PIR is safe, okay? Connection is closed, okay? Which means it's powering this relay. Relay's got 3 terminals here. A common, and normally, that's where we draw it. We should draw it like that. Say that's your relay here, okay? You've got a normally open and a normally closed. That means when there's no power applied to the relay. We're not worried about the PIR. That's no power applied states, okay? So PIR is closed, or it's safe, it's not seeing any motion, so it's closed, powering the relay. So we should ideally connect the switch across our common. Let's go like this, normally closed terminal. So, okay, it sees motion. Ooh. Releases the relay. This drops to the normally closed. Transmitter button gets pushed, and then it sends the signal, and it doesn't flood the neighborhood with 433 meg remote control jamming signal. So let's find a small relay and give this a shot. Let's open the remote transmitter here and see what our current draw on it is. So here we go. It's actually quite a nice little construction in this remote transmitter. There's a little push button, a little, what's that little bodge resistor. I don't know if you can see that little resistor that's busy dancing across there. That's just a 0 ohm link. Don't know why they did it like that, but anyway. Okay, so now the tester is in series with the transmitter. Well, as soon as I can get these crocodile clips to agree with me. Okay. Okay, let's see. My test is not the most accurate, but according to this, when the button's pushed, nothing. I mean, when the button's not pushed, the current, standby current is too low for my tester to actually show. Let's go 200 milliamps and push the button. Ah. So when it's transmitting, it is 28.9 milliamps. So let's say 30 milliamps. Okay, so let's work out, just for interest's sake. We said that it draws 30 milliamps, and we got 12 volt supply. Okay, well, let's work out the power of this transmitter, because it is rated as a medium to long range transmitter. Okay, so 12 volts times 30 milliamps equals 12 volts times 0.03 amps equals 0.36 watts. So it's just over a third of a watt that this transmitter transmits at. That's quite interesting. So let's find a relay and modify. Go dig through my parts bin and find a 12 volt relay. Okay, so I found a relay that's got a 12 volt coil right over there. Let me try desolder it and see how it goes. It's not quite nice, little small relay. So I'm just going to add a bit more solder. It's a 5-pin relay, which means it's giving us normally open and normally closed terminals. Now I'll send it flying across the room. That's okay. Okay, so there we got a relay. Nice. Good relay. Okay, so now we just need to put a few little wires on. Okay, first we need to determine where I have lost my diagram. Okay, there we go. That's what we said we're going to do. Okay. So we need to figure out which is our coil on the relay. Okay, so without anything connected to the circuit, the coil will be the terminals that's showing a resistance between them. Not a low resistance like the 0 ohm short, because that is the normally closed terminal. So nothing on there, there. Let's try those two. Okay, we are getting 0.450 kiloohms, which means that's 450 ohms. So those two would be our coil. Okay, and then which is our, we wanted to use our normally closed terminal. So we're most likely going to be the sensor, being common. And if we go down to that one, okay, so that is our normally closed. Easy. Okay, so let me draw it on the relay. So we've got a normally closed over there, and we've got a normally open over there, and then our coil. So we're going to connect the switch part of the remote transmitter across the normally closed terminals. So let's rip some wire. Rip and strip. I really do need to find a set of cutters. I'm just using little mini pliers. Is this it? Ah, there we go. There's my little cutters. And we said normally closed terminal according to our diagram. So let's do this neat. I'm going to cut this one a bit shorter. The nice thing about the way we're doing it now, keeping constant power onto the transmitter, is we can just push the switch when we need to test. Okay, so there's our normally closed wires there. And the closed terminal that we're going to put onto the transmitter's switch. First I want to get rid of these battery terminals on the transmitter just to make it neater. It is marked, so yep, there's positive, there's negative, so just drop that out the way. Onto my lap. I'm glad I'm wearing jeans. By the way, I've just voided the warranty on this transmitter. Now we need to see which terminals on the switch, because the switch has got 4 terminals. 2 should be the normally open contacts, and 2, and they should just be bridged together. So let's go ohms, beep beep. Okay, continuity. So if I'm looking across those two, I don't know if you can see them too well. Top and bottom, 0 ohms, 0 ohms. So those, so the left is joined together, left top and bottom, right top and bottom are joined together. So I can just put my wires from the relay onto those two terminals under that switch. Too bad my relay is a bit too big to fit inside the box itself. Oh. Okay, now to, it's not micro soldering, it's not like Lewis and working on a little laptop board. See, all those things are tiny, and cell phone boards. Compared to those, this thing is huge. They would laugh if I said this is micro soldering. Okay. Okay, so there we go. Now the relay is in control of the transmitter switch side. Now we need to give it some positive and negatives. Where did I lose my... Anybody see where I put my other long piece of wire like that? Probably on the floor under my toes. Yes, it is. I've got minuses and I've got dots. Okay, the minus will be the negative on my way. Okay. I hear somebody trying to open my door. Dun, dun, dun. Okay, I've had to pause it a few times. Don't you hate getting a cramp in your leg when you're busy soldering something? Then you have to just get up and go for a walk around and the cramp comes back the very next time. Okay. So that's fine. We've got our positive with our dots, our negative with our stripes. Okay, and we said that our relay is going to be joined. Oh, okay, my diagram's a bit screwy here. Thanks for telling me, guys. If I find my pen, the relay is supposed to be joining up to the positive because we are switching the negative. So what we are going to do, we're going to take the relay and join up to the positive with the transmitter's positive. So let's, where did we, there's a coil, so we're just going to tap it over there. Am I off the shot? Sorry. And then I pricked my finger in the relay. I wonder if you saw that. Yo! I got relay fingers. Doo, doo, doo. Okay, so now we are going to pick up the positive. Okay, so now we have our positive for the relay common with the positive for the transmitter, which is going to go into the sensor. And then let's choose a different one to give us our negative on the relay's coil to pull in the relay. So we just go for a different color. Okay, so there we go. We've got a positive, we've got a negative, and we've got a constant positive, constant negative, and we've got a switched negative to pull in the relay's coil. now we can figure out what I'm doing wrong. I'm not trying to squeeze it back, I'm trying to put it into the wrong transmitter. Okay, there we go. Zoom out a bit. Oh, sorry. Okay, I need to take a nibble out of here. Hope that's not an important part to hold it together. Trick is to make sure it's all click, 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 click. Trick is also not to lose my transmitter screws. That sucks. It's longer screw, I hope it's for the transmitter. I was going to get the hole in the other side. And my camera is warning me that I've got 4 minutes battery life remaining. Okay, so there we got our transmitter, there we got our relay, there we've got a bunch of wires, and pieces of our motion sensor. So let me put the motion sensor back together, wire it up quickly, and then I'll be back. Okay, so now I've got my sensor connected up. That's hiding under this paper for now. They've got the relay over there, and the transmitter over here. The push button still works. And I've got a receiver similar to what the customer has at their premises. So I'm going to show you how we're going to code this transmitter into this receiver. So this receiver will mimic what's happening to the transmitter. So we're going to hook up the power. Beep, beep. Okay, so I've connected this up to power on just a separate battery. I'm going to hold this learn button in. And it's beeping like crazy. What that's done, thank you. So what that's done now is that's erased all remotes out of this unit so that the old faulty remotes or any other remotes that are lying around won't be able to trigger anything. Okay, so now I want to learn this remote. So we push the learn button and push the remote. There we go. And we can push the learn button again. Now if I push the remote, you can hear the click. Okay, let's put a tester on there just to give you a beep. I'm putting it onto the normally. Let's go to the normally open contacts. Okay, this is a test, and I'll push the transmitter and you should hear the tester beep. Okay. Okay, so that shows that the receiver is getting a signal from the transmitter still. Let's go to the normally closed terminals on the receiver, which is where the alarm system would normally be wired to. So it's seeing a short at the moment, which is the same as the existing circuit where the passive would be given a short to say that everything's okay. Push the button and you can see straight away you can hear straight away it releases and goes open circuit, and then the alarm system knows how to react to that. So now let's go back over to these other terminals, the normally open terminals, and I'm going to uncover this PIR sensor, and then it's going to start transmitting and the receiver is going to start receiving. Okay, let me move it up to look at me and to look at you. Hello, and there we go. So you can see when the sensor is receiving motion, it's triggering the transmitter, which is triggering the receiver, which is triggering my multimeter. Okay, hello. Okay, now remember we said but the PIR is directly onto an alarm system. It's normally closed until it sees motion. So let's see. Okay, I must remove that. Okay, so now it's normally closed because it's not seeing any motion. So the circuit is safe, the area is secure. As soon as it sees motion, it's going to transmit, the receiver is going to open the circuit, and then the alarm system is going to know, like that. Okay. So that is switching the mode correct now. So we're not transmitting the whole time, we're only transmitting when we get an event. Okay. Now some of you are going to say, yes, this isn't secure, you need normally closed through the whole way. Yeah. You need normally closed through the whole system to see if anybody tampers and things like that. Yes, you do, but for that type of system, you'll need to have more secure, like a transmitter that'll send a status saying secure or insecure, or you need to hardwire it, which is the best method. This is just for a tool shed, so it doesn't have to be ultra secure. It's just so that they'll know that something might be happening there. So now I am going to close this up and go put it in at the customer's place, and then they should be happy. So I hope you've enjoyed this video. Hope you've learned something and enjoyed it. If you did enjoy this video, please give it a thumbs up, subscribe to my channel, and click that little bell icon to let you know whenever I upload new videos. And this beeping is going to be very irritating, so I'm going to switch this off soon. Thank you.